now I call upon on stage Mr. Ravindu Patirana, co-chair of the YSCMR, to deliver the welcome speech for this occasion.
Good morning, ladies and gentlemen. Welcome to the 5th Young Scientists Conference of Multidisciplinary Research 2023. First of all, I would like to welcome our keynote speakers, Professor Saman Halgumage, Ms. Rashindri Pereira, and Deshani Poddenige, the chairman of the NIFS, Professor Abdul Sumatipanda, the invited speaker, Professor Iran Edirisingha, the director of the NIFS, Professor Saluka Kodituaku, all the scientists in the NIFS, academic and non-academic staff of the NIFS, and all the presenters who join with us for this conference from all around the world. The YSCMR 2023 highlights the dedication and hard work of these talented researchers who are exploring new horizons of knowledge in various fields. This time, the YSCMR 2023 is organizing under 5 themes: biological sciences, chemical sciences, physical sciences, computer, statistical, and mathematical sciences, and social sciences by representing more than 150 abstracts. I would like to congratulate all the presenters who have joined with us for this conference. Thank you very much.
Thank you, Ravindu. And now I would like to invite on stage Professor Saluka Kodituaku, Director of the National Institute of Fundamental Studies, to address the gathering.
Good morning, everybody. Professor Abdul Sumatipala, Chairman of the NIFS, and our leader of the keynote speak team, Professor Samal Halgamua, and his team members, administrative staff of the NIFS, and the scientists and non-academic staff members, and then the young scientists and the participants of this conference. They are the director of the NIFS. I'm very happy today because according to our act, the NIFS is expected to deliver many outcomes and the outputs to the society. And the mainly first thing is our act says that our objective is to carry out fundamental research. Basically, fundamental research means the basic sciences research. And main objective is, though some people do not agree with us, that is the generation of advanced knowledge. The generation of advanced knowledge is not anyway mean that we should end up with the tangible products. And then the second objective is to train young scientists. So that means we want the experienced eminent scientists carry out their own research in respective fields, and the NIFS and the country expect them to train young generation to become a senior scientist one day. So that is why NIFS appoint or recruit young scientists in all the research programs of the NIFS. And the outside people misunderstand what the NIFS is doing or what the NIFS has and so on. But ideally speaking, based on the various scientific fields, we have multiple research programs. Within the multiple research programs, we have multiple research projects. So basically, and for those research projects, we hire, or in other words, simply we recruit young scientists. That means the mainly fresh graduates and the young people with postgraduate qualifications like MScs and MPhil. And today, this event is organized by that particular group. That means the body scientists or RS of our institute, and also under which that means the training young scientists, the NIFS provide another opportunity, not for the graduates, but we provide the opportunities for undergraduates as well as school leavers. School leavers mean A level, that A level or advanced level performers. And then we hire them as volunteer researchers. Volunteer researchers. I'm pretty sure today, and then our team of RAs or research assistants and these volunteer scientists together organize this particular event. And when we consider about our senior scientists, unfortunately, though we have 29 cadre positions, we have at the moment we have only 16 senior scientists. Under them, or they are under their leadership, we have 39 research assistants. They are the key pillars of the research activities carried out by the NIF. Senior scientists lead the research groups as well as the research projects, and then the young scientists assist them to carry out this research. And when you carry out your own research, and then the society or the government or the ministries, they expect whatever the research outcomes and the outputs to be shown to the society. But unfortunately, as I mentioned at the beginning, the fundamental research doesn't mean that the producing the tangible products, but whatever it is. And then if it is advanced knowledge, one way of dissemination that knowledge is to publish them. And then the NIFS scientists, senior scientists, as well as the young scientists do it continuously. It is an evidence of annually a number of research publications produced in high impact journals internationally as well as the locally. But as young scientists, when you carry out your research, in generally, this is from my own experience, as the young researchers, during their research career, we are under stress. Why? You are carrying out research according to your supervisor's guidance, advice, but whether what you are carrying out is good or bad, or you are heading toward the correct directions or wrong direction, that is observed by your senior scientist, that is your own supervisors. But in order to know whether whatever the research outcomes or outputs you produce at the end of the day is acceptable by the wider audience, locally as well as the globally, and then you have to publish them. That is the way. When you publish those research outcomes and the outputs, then only other eminent scientists, obviously your supervisors, will understand the value of your research work, because you are carrying out those research work under their supervision and their advice. But when you publish it, then only you get confident. And then when you are getting motivated, once you get to know that what you are doing is having a value for the betterment of the society, as well as there is even a little contribute to the development of the science. So that is why your supervisors always encourage you to publish your research work. It may be in the journal paper, or maybe a full international or local conference paper, or an abstract, whatever it is. Once you try to publish it, if it is a journal paper, then obviously you will get the feedback from eminent scientists, or simply we call reviewers. They will examine or assess your work, and if there is a positive side or a negative side of your work, they will provide a constructive feedback for the improvement. That is very, very important for improving as researchers. And when it comes to the international papers, and then even better opportunity is there. And when two reviewers review it, and similar to the journal publication, reviewers provide the feedback. And then in addition to that, you have to present your work in front of scientific audience. And then in that audience, the eminent researchers, those who have a lot of experience about the research, that means they may have their own struggles, own success, and all those things is very valuable, because after listening to your presentations, they will tell you what are the positive facts of your research work, as well as how your work could further be improved and so on. That is a very important thing. And because of that reason, conference of this nature, I believe that becomes a platform for young body scientists to improve their research work. That is the first thing. And the second thing is, though I am standing here as the director of the NIFS, I am a university academics. And then as an academic, just say since 2010 or after 2010, we got opportunities to work with very talented, the hardworking young generation who have shown high colors at the GCE A-level examination. Maybe 3 A's, 2 A's and B, A, 2 B's, 3 B's, double B, C, and so on. But unfortunately, due to the, personally for me, unacceptable education system in Sri Lanka, they have been trained for examination race. Nothing other than that. Examination race. They just, in our terms, we call they are cramming. That means they're reading, and then practicing the answer in the past examination papers, and then earn good grades. Once they will enter the university, the culture is entirely different. And from since then, they have to answer exams just not cramming like the A level, but you have to think, or basically we call, you should have abilities for analyze, modeling, synthesize, and all those things are necessary. But unfortunately, this during the A level examination process, they have not been trained for that. And because of that reason, even at the university, lecturers teach them, lecturers prepare the exam, lecturers assess the exam. Still, undergraduates are struggling to answer the examination questions where critical analysis, modeling like requirements is there. And then even the research. For you, somehow you have completed your undergrads and now you are fresh graduates, join at NIFS and carrying out the research. And then when it comes to this body scientist research, and then when we review these papers, it may be a conference paper or maybe an abstract or a journal paper. And then many such young scientists lacking one thing. What is that? From my experience, they are very good researchers. They carried out their research. But when you present it to the scientific audience or reviewers, and then many fail to justify their work. The work is very good, outcomes is very good, but fail to justify the work just because they forget to validate the work. Validate the work. And that is where you need analytical skills, in particular nowadays, statistical analysis, and then you are interpreting your results statistically, so that the reader can clearly see that whatever the work you have carried out and your output is having a value and there is a contribution to the respective field. But that is why you all have been assigned a supervisor, because your supervisors are very experienced and they're the globally known eminent scientists. They know how to present a research outcome. And that is why we advise you, whenever you publish, before you publish, you should draft your paper. As I mentioned, maybe a journal paper or maybe a conference paper. The first person you have to show it is to your supervisor. Not only the paper, the other thing. A conference like this, you have to present, right? And in that case, you could be a excellent, so you will be a person with excellent communication skills. But even you are a very good speaker, if you fail to pass the exact message you want to pass through the presentation you use, usually nowadays you use electronic presentations. If the content does not convey the exact message, or in other words, if your presentation does not compatible or match with your paper, that is a problem. That is why we always advise young body scientists to, okay, when you go for a conference, prepare your own presentation, and then the first person you should show it is to your supervisor. Because the supervisor knows the work you are carrying out. He is the one who advise and direct you towards success, and they will be able to understand whether the paper and the presentation say the same thing. And those are the things you have to develop. And on the other hand, not you, but you are here as the research assistant. And then again, from my own experience as an academic, when we produce the graduates, and then when they join the industry, it may be, when we say industry, it may be a state-owned organization or a private organization. Many of the private organization administrators comment on the Sri Lankan state university graduate is the lack of soft skills. Lack of soft skills. And then main thing is organizational skills, team spirits, the communication skills, and those things. And then organizing a conference or event of this nature give the opportunity for you to develop your soft skills. And obviously compared to the our days as young people, and then most of you are having a very good English knowledge compared to our English knowledge when we were undergraduates, because we came from very rural areas with even the school there wasn't the English teacher like situation, but majority of you are not like that. Perhaps you have gone to the so-called English classes, what we call elocution classes and so on, and therefore speaking in secondary language, that means English may not be a problem for you, but as I said, but the speaking and then the communication skills is two things. And therefore, you have to improve that communication skills. And then when the other hand, when I say that team spirit, if you cannot work with others, I'm very happy here because I have seen that how you all are working together as a single team for organizing this kind of conference for 5 consecutive times. And I hope this trend will continue in the future as well. And I have to say one more thing. Don't think that I'm blaming you or criticizing you, but this is the truth. This is the truth at the university. And then even I was here the last year this young scientist conference as well. And then the audience keeping silence. The audience does not mean that only your supervisors or the NIFS senior scientists. What I have experienced last year was when one of you present your work and when the session chair declared that, okay, presentation is over, now presentation is open for discussion, entire young scientist crowd is dead silent. Nobody asks any question. Then who are the question? Obviously, supervisor doesn't ask question. That is unethical. I mean, basically, even the supervisor is there. Supervisor depend you only if it is absolutely necessary. Otherwise, supervisor is silent. Supervisor is silent. But the other RA supervisors, or just for example, if the Professor Rohan Veerasurya's RA is present in the work, Professor Rohan Veerasurya keeps silent. And then who are the question? Either Professor Lakshman, Professor Cyril, Professor Bandara, Professor Deepal, Dr. Lakmal, but you are not. You are not. But that should not be the case. You should ask questions. You may have your own experience saying that, sir, I am carrying out the geological or earth science research. Then what should I ask from the environmental science, RS? No, that is not the. You may not be able to ask specific subject matter questions. But there are many other questions you can ask because there are, except the subject matter, there are many other common facts in conducting or carrying out research. Now, you should develop that. I'm not saying that the ability or anything. You have to develop that practice. That is the practice, nothing else. And otherwise, once you complete your research career at NIFS, and one day when you step into the society, another different world. Right? The people are different, the behavior are different, and then you may not work under scientists. It may be a CEO, and the other important thing is that CEO may not be an educated person like your supervisor, right? Their main objective is profit making, nothing else, and therefore you have to work under them to help them to increase the profit. And that is why they say that your graduates or your undergraduates, your fresh graduates or your postgraduates, they have very good technical knowledge. They may have very good presentation skills, but they are lacking the team spirit and the leadership. But these are the activities you can develop those things. So that is why I said, as the director, I am very happy to see NIFS Young Body Scientists annually organize this particular event. And 4 successful events were concluded, and this is the 5th one. And then thanking our scientists for leading these young scientists to, toward the respective research directions and guiding them for their success, as well as helping to fulfill the responsibilities of the NIFS as the institute. I wind up my speech by wishing you a very successful conference. Thank you very much.
Thank you very much, sir. The chairman of National Institute of Fundamental Studies, Professor Atula Sumatipala, is joining virtually with us today. We are very humbled that you took some time off your busy schedule to grace us with your presence in this event. And now I would like to invite Professor Atula Sumatipala to address the gathering.
Good morning. Thank you. Professor Saman Algamuge, my dear friend, who is one of the keynote speakers, Professor Ranidri Singha, Director, Professor Shaluka Kodituaku, Senior Professors, Academics, Research Assistants, young scientists, good morning to you all. At the outset, let me apologize for not being able to be there physically because I was there very frequently over the last few days and I'm coming back on the 11th. So that was the reason I'm joining through the Zoom. Now, let me also thank the organizers for inviting me to say a few things about it. I just want to endorse the excellent speech made by Professor Saluk and the points he brought up, very crucial. But I want to reinforce 2 or 3 messages from his speech. One is he mentioned about the importance of fundamental studies, which nobody can dispute. The Institute for Fundamental Studies was established because at the time, the political leaders as well as the scientists knew the significance and importance of fundamental studies. Having said that, remember, these fundamental studies you all carry out will pave the way for advancing science, for applied research and implementation and developing products and services in the future. It's a chain, it's a long process. And also remember, social science and humanities were included in the original act because that is also part of fundamental sciences. Now, Professor Shaluka also mentioned about the importance of sharing your findings in a conference like this or through publications. It's very important, as he very correctly reiterated. Sharing your finding is not for the sake of sharing. That's for peer review, critical comments, and others to see what you could have done, you missed, because everything cannot be done by 1 or 2 people, and to reflect and to give a feedback, what we call the peer review. So all these are very, very important. I also want to thank the organizing committee for their strategy. I always say strategy is capturing opportunity. Professor Ranidri Singha came. You all had a meeting with him. Now you have captured that opportunity to invite him to give a talk on AI, which was very, very appropriate. Now I want to say a few things very briefly. As my talk, some thoughts to share. As we all know, the 21st century began with unusually rapid development in technology and communication. A new technology can become obsolete even if it is introduced to the market. In such a rapidly changing world, the skills necessary for learning and employment, including creativity, innovation, critical thinking and problem solving, communication, teamwork, information management, effective use of technology, professional and technical life skills, and cultural flexibility. The most recent advance is AI, which you will hear from Professor Ram. The post-industrial knowledge economy of today clearly displays that close correlation among economic growth, innovation, and indigenous research capacity. University-based research has been the most effective driver of such economically relevant innovations. As a result, leveraging the public investment in universities to stimulate innovative research and development is now a critical need for a country to remain competitive in the global arena. Most high-ranking Asian universities have transformed themselves from teaching universities to research universities in keeping with global trend. I'm so happy that Institute of Fundamental Studies have full-time academics, professors, researchers, whereas the other universities, they have to do teaching. Sri Lanka needs a paradigm shift to make research and innovation core component of undergraduate postgraduate education in order to produce individuals with both a creative vision for innovation as well as sufficient intellectual breadth and depth to realize that vision. However, as Professor Shaluka correctly pointed out, if you don't have the necessary soft skills to share that knowledge for the people's benefit, the knowledge you have created is not going to serve the nation. The Sri Lanka requires innovation R&D contribution to re-stabilize the economy, to ensure national security and for sustainable development in strategically important areas. However, the strategy is about capturing opportunity arising in a dynamic world, as scientific opportunities cannot always be foreseen. The flexibility to respond to novel ideas with solid potential and new funding opportunities for research is therefore crucial for success. Research universities work on basic and applied research for knowledge creation and dissemination. And through collaborations with industry, they can set up mechanisms to utilize this knowledge effectively for intellectual property generation and knowledge technology transfer for commercialization. So that's part of the process. One person doesn't have to do that. You do fundamental studies, which can be carried forwards by other people, because you leave some substantial fundamental knowledge for them to work on. The key component of this transformation need to be reviewed as paradigm shift is in strategy to increase resource through investment, spot and harness young talent, recruit and retain, which is very, very important, best researchers and make essential structural changes. It is crucial to establish quality research centers of excellence and raise funds for research through collaboration, develop capacity to compete for international grants, and enhance research findings through endowment. There should be more research-based postgraduate programs around large-scale research projects, leading to implementation for meaningful impact. So I very much hope the young scientists at NIFS will be capable of giving the leadership needed for such an overarching research culture to be created in Sri Lanka. A magnitude of a conference of this nature is not easy. So I heard there are over 100 abstracts. Getting them, reviewing them, organizing, and particularly giving opportunities for people to present and participate through Zoom for knowledge sharing is a real challenge. There are technical hassles, there are other resource hassles, but you all have stood up to that challenge. And I'm very glad as the chairman, day by day, that ethos and culture at NIFS is enhancing, strengthening. As Professor Shaluka said, I have met actually even last Saturday, some of young scientists who are very, very enthusiastic, energetic, and I do see their passion. And through all that, I do see future budding scientists within them. I very much hope you all will give the leadership that is needed to our young budding scientists and continue this work further. I'm not going to say anything more because there are 2 speeches to be made, but I'm very glad that this event has been held over 5 years in spite of all the challenges we have faced. So during my tenure and even after that, even if I'm not there, I will always see that whatever the contribution I can make, I will make. And one of the strongest steps we have taken recently is to link Kiel University with NIFS. So that opportunity has been created. I'm very glad that you all have invited the Pro-Vice Chancellor, Professor Iran Edirisinghe, again a patriotic Sri Lankan, to take that challenge further with you all for the next many years. So thank you very much for giving me this opportunity. I wish you all the best for the day's proceedings. And I'll stop there. Thank you.
Thank you very much for that enlightening addressing, sir. The keynote speech of the day will be delivered by Professor Saman Halgamuge and his team, Ms. Rashindri Pereira and Ms. Deshani Poddenige. And now I would like to invite Director of National Institute of Fundamental Studies, Professor Saluka Kodituaku, to introduce our keynote speaker.
Okay, as already announced, today's keynote speaker, though we say keynote speaker, that's a team of research group team members headed by the Professor Saman Halgamuge. Professor Saman Halgamuge is a fellow of IEEE, IET, and AAIA. Received his BSc engineering degree in electronics and telecommunication from the University of Moratuwa, Sri Lanka, and the diploma engineering and PhD degrees in data engineering from the Technical University of Darmstadt, Germany. He is currently a professor of the Department of Mechanical Engineering of the School of Electrical, Mechanical and Infrastructure Engineering, the University of Melbourne, Australia. He is listed as a top 2% most cited researcher for AI and image processing in the Stafford database. And then Professor Saman Halgamuge will be assisted by his team members or research group members, Rashindri Pereira and Deshani Poddenige. During this keynote speech, they have selected the title, The Computer Vision with 21st Century Artificial Intelligence. They explore the exciting possibilities of computer vision enabled by the power of 21st century AI. They also discuss two directions of the AI of their own research group, focusing on enable machines to learn and reason fast. Additionally, they will describe how these AI methods can be applied to various vision tasks, including medical image vision applications and deep fake detection. Professor Saman, the floor is yours. Thank you very much.
Hello, everyone. And my name is Saman Alkamuge. And together with Rashindri Pereira and Deshani Poddenige, we will be delivering this talk in computer vision with 21st century AI. I apologize for not being there in person to deliver this talk, and I'll be recording my few minutes of the talk, and then other two presenters will be delivering live. The reason is I'm currently traveling in overseas, and so it's difficult for me to be there on time to do the presentation. So we are, as you can see, is from AI Pattern Recognition and Optimization Lab, which is a research group within mechanical engineering at the University of Melbourne. And although we are called mechanical engineering, we are in mechanical engineering. We do quite a lot of work on AI and biomedical engineering, as well as energy and environment-related applications. So today we are going to talk about computer vision or machine vision and some of the work we are doing, and some of the work we are doing in cancer research in particular, but also some work we do in deepfakes research. But first I want to say something about intelligence. general intelligence, as you may have heard, and people believe that if someone is intelligent, and then you can actually think about analytical intelligence, for example, and that it's something that, for example, bright students will have, academics will have, and then there's another level of intelligence called creative intelligence that we would expect from an artist, for example. Then there's practical intelligence, and then, as you may have guessed, then politicians should have practical intelligence. And another word is street smartness and common sense. So this is broadly these different types of intelligence available, and as we know in sciences, and there are also further refinement. And but where do this intelligence come from? Is it only human, and can we also see this in animals? And you have seen this tree, and one would say, and this is quite intelligent. So in Sri Lanka, in Sinhala, it's called Nidhikumba, mimosa, proper name. And then there are these sort of ants that harvest food and for their children, and by using this tree leaves, and they take them underground, and then they harvest some sort of fungi, and that the ants can feed to their babies. So I think that is sophisticated intelligence. So we are not the only one as humans who claim to have intelligence, and this is also common in animal and plant kingdoms. So now, if you talk about artificial intelligence as opposed to this natural intelligence, and because it's now made by us, right, and therefore it is called artificial intelligence. And there are a few ideas of how this can go wrong, for example, and there are a few things I listed here. But for us and AI researchers, and this work is basically finding solutions for a problem, starting from some approximate solution, and then we try to work towards a much better solution and for a given problem. So this is true for almost all AI application that includes generative AI and so on and so on. So mathematically, it's an optimization problem that we try to solve. Okay, so but now coming back to computer vision, and computer vision has its impact since the deep learning was used in computer vision, and so many years ago, decades ago, computer vision people didn't even bother to look at AI, but now you can't do computer vision without AI. Okay, so what is computer vision? So it is basically looking at images, understanding, making sense of it. And if you look at this left-hand image, and if you have done a little bit of history, you would straight away see this is Lincoln, right? Abraham Lincoln. So now we can create a machine learning system to actually look at this and figure it out that this is not Obama, it's not Trump, it's not Biden, so it must be Lincoln, right? So how do we do that? And convolutional neural networks, you probably may have heard it, and change the world, and how to computer vision, and how to actually capture information in a sequential manner. And so that goes on further, and this development, now we are talking about generative models today. And on the left-hand side, you can see these pictures generated by AI. So they look very real, but they all are fake. So that brings us to the question, and do we one day have humanoids running around amongst us, saying hello to us, and we do not know whether they're real or fake, right? Can this technology go that far? So now we have worked on both generative models as well as discriminative models. The generative models is what you would find in ChatGPT, for example, and but there's also a discriminative model. That means we use AI to separate a class 1 from class 2 patient 1 from patient 2, and for example, in pandemic times, a variant 1 of the virus from the variant 2 of the virus. But in generative models, it's quite different when you look at it. But conceptually, there is some lot of things that they also share. Okay, so now I jump to this work that we published in October, and the 2 other co-authors are involved in this work as well, and both of them co-authored this work, but it's led by NUS, National University of Singapore, together with some members in my research group. And this was a really nice paper. It's called Undercover Deepfakes, Detecting Fake Segments in Videos. You will hear a little bit more about this as you go. And one concept that that you might find familiar is what we call diffusion networks or diffusion models. So you can see this dog on the left-hand side get less and less of a dog if you go to the right. So you keep adding more noise, and the right-hand side, and you won't even see that there is a dog in it. But then the trick is to bring it back to become a dog. And by doing so, you can do all sorts of manipulations. And maybe you start with the dog and you go to this right-hand side in, and then you come back to the left. You make some manipulation for this picture to now appear like a cat, right? You can do that. You can destroy the image and then bring it back. And it's like a diffusion process in science, and then reverse diffusion, and but with some manipulation. So this is an interesting technique that some of us work on. The loss of machine vision applications. So here it is about finding whether people in a company work without the required clothing, and and here of course we all know about this development. Autonomous driving is still kind of a dream because it's not completely fully there, but lots of people on Earth are working on this problem right now, and lots of big companies as well as universities. And here's a very nice application I like. So it can be a computer app, and this is about finding hotspots in solar panels and using simple phone-based application. And as I heard, so it's a you can read about these things, and these things do exist in real life today. So that brings me to kind of last slides that I want to present, and then pass on to the other people and to talk about. So this is the summary of the work we are doing. So on the x-axis, what we call democratization of AI, that is we are working on. On the y-axis is what we call interpretation of AI. So we basically work on the interface between interpretation and democratization of AI. So with this slide, I pass on to other 2 people to take over from here, and I stop here, and thank you very much for listening to me.
Hello, everyone. I will continue the speech from here onwards. My name is Deshani. I'm a PhD student from Professor Saman's research group at University of Melbourne. Today, I have the privilege to speak with you all about a very exciting computer vision project that we were part of, which is related to deepfakes. During our professor's presentation, he has mentioned to you about deepfake detection related publication we did in this year. So in my presentation, I'm going to talk a little bit more about this publication, as well as in general about the deepfake area. So first of all, what are deepfakes? Deepfakes refer to synthetically generated media using deep learning techniques. So if you take deepfakes word, so deepfakes are so deepfake word is created by combining deep learning and fakes together. Typically, deepfakes are associated with manipulated videos, but there are deepfake images, audios, and all sort of contents out there. But during my presentation, I'm only focusing on deepfake videos. And when I refer to deepfakes, I'm talking only about deepfake videos. So in my slide, you could see some of the video clips that I've taken, which are created using deepfake technology. So for example, here, Elon Musk's face is sort of swapped into a wrestler's body, and Einstein's face is moving, and here Tom Cruise's here's a Tom Cruise's fake video. I think for me, I can't even say this is a real one or fake one because it seems very realistic. And in Tom Cruise's case, in fact, there is a separate page with in TikTok with all sort of deep fake videos of his. If you're interested, you can check it out. So if you talk about deep fakes, it has real use cases. It has been evolving over time, and it came to a situation now we can't understand what is real or fake. It's so realistic. And I will talk about some advantages of deepfake area. One of the main use cases is that we can use deepfakes in film industry. For example, if you want to translate one movie to another language, if you have, let's say, English movie, and if you want to translate it to a Sinhala movie, we can use deepfakes, like as we can manipulate the mouth movements and everything. Another example is that we can use it to generate personalized advertisements. So I have seen this advertisement with Shah Rukh Khan. I think all of you might familiar with him. So there was this advertisement that he was referring to thousands of local businesses in that advertisement. But instead of filming all the 1,000 different versions, what they have done is they have used deepfakes to generate those ads. So it's there with real world use cases. And next, I will talk about what are the actual threats in this domain. I think all of you can understand. It could be very dangerous to the security and everything. So one use case would be like there was this Ukrainian president issuing a video saying some commands to his troops, but later found out that it was generated using deepfakes. So it could be used in very malicious use cases as well. And another example would be forging evidences to the jury. So all sort of things people are misusing this technology. And we can find lots of such use cases in today. Because of that, I think it's clear to you that it's a timely requirement for us to build sophisticated AI models to detect all sort of deepfake videos or images and etc. But in our research, we are focusing on building deepfake detection models. So with that, I'm going to discuss a little bit more about our research paper that we worked on. So this is the name of our paper, Undercover Deepfakes, Detecting Fake Segments in Videos. So in this project, we collaborated with National University of Singapore, or NUS. The problem we address here are that most of the deepfake detection methods in the literature are focusing on the videos which are entirely fake. However, there's another category of deepfake videos which are manipulated, which are only a part of the video is manipulated rather than the entire video is fake. So For that kind of videos, there are no much deepfake detection methods in the literature, and it's unexplored. Therefore, in our research, we try to address this problem and provide a solution to provide deepfake prediction at the frame and video levels. So by video levels, I mean, given a video, we can predict whether the video is fake or real. And frame level, we can say what are the frames that are forged. Moving on, to facilitate our research, we created this new benchmark data set because to the best of our knowledge, all the publicly available data sets are entirely are consisting with the videos which are entirely fake. That means all the video frames are fake. Therefore, what we did was we curated this data set here. What we have done is in between real videos, we have added fake frames to facilitate our studies. So using this technique, we have created a data set according to our problem. And we refer to phase forensics or FF++ data set in generating this data set. So that's one of our contributions. And the next contribution is the deepfake detection method that we introduced. The classical detectors in deepfake literature, what they usually do is when we input a video to a classical detector, it will tell us whether it's real or fake. But in our case, this is our temporal segment detector. So in addition to outputting real or fake, basically video level, this is a video level label. In addition to that, our detector can detect what are the fake segments. So starting from this frame to this frame to this one, likewise, it can detect what are the segments which are forged in our video. So here is our detection methods model architecture. I will give you a high-level understanding for our architecture as well. In our model, what we did was we have two components. The first one is called vision transformer. So in the vision transformer, what we do is we divide our video into a set of frames. And what we do is we get a classification as real or fake for each of the frames in the video. And then we extract the feature embeddings from the vision transformer for each frame. And then we organize or accumulate those features into a sequence. In the next step, we use moving windows and input these moving windows of the feature vectors into time series transformer. So time series transformer is the one who capture the time series or temporal information of our video. So the time series transformer will then give us the result of what are the segments, what are the temporal segments that is classified as real or fake. So that's basically a high-level understanding about our model. And with that, I've again added the details of our paper. So here's the link to our paper. And if you're interested, please feel free to go through the paper and contact us if you need more information. With that, thank you very much. Over to you, Rashindri.
Thank you, Deshani. Good morning, everyone. Thank you for giving me this opportunity to speak. My name is Rashindri Pereira, and I will be representing our group at the University of Melbourne. So in the previous slides, we looked at the capabilities of AI in generating deepfakes, and our solution for dealing with the deepfakes that are generated. In the next set of slides, we will be shifting our focus to a more positive application of AI. Here, we are looking into the application of artificial intelligence for processing medical images to help. And by doing that, we aim to help doctors, clinicians, and pathologists in providing diagnosis and prognostic treatment to patients. So when we talk about medical images, there are many types of medical images in medical diagnosis. So I have added just some of the examples into this slide. Among them, in our work, we mainly focused on whole slide images. And whole slide images capture microscopic perspectives of the human body and thereby allow, again, doctors to understand the diseases and the diagnoses that are required to provide patient treatments. So when talking about whole slide images, these are digitized representations of tissue sections. And these representations provide us in gaining an understanding as well as a visualization of the tissue environment. These images are generally captured at very high magnifications in order to capture all the minute and finer level details such as the cellular structures and so on. And because of being captured at very high magnifications, these images are generally gigapixel in size. For example, one image can contain around 3 billion pixels on average. And because of this large size, these images are generally computationally costly to be processed in a typical deep learning network. So in this work, we aim to develop a neural network which can process these very large images in a cost-efficient manner. Now I'll give an overview about the exact problem that we are focusing while trying to process these images. So these whole slide images, as I mentioned, are digitized tissue sections, and they generally carry large amount of information in them. But in this specific problem that we are looking at, we are interested in a set of cells known as tumor-infiltrating lymphocytes. So tumor-infiltrating lymphocytes are lymphocytes which move from the blood into a tumor environment or into a cancer environment in order to mediate an anti-tumor response. That is, they move into the tumor microenvironment to fight against the cancer cells. Because of these reasons, TILs have become an important biomarker in multiple tumors, including breast cancer, as they have been proven to provide favorable correlations with treatments as well as patient survival. The animation that I have added in the slide shows immune cells within a cancer environment. So these protruding immune cells, or the tiny blocks that are protruding out, are the TILs, or the tumor-infiltrating lymphocytes, which we are interested in. When talking about the importance of TIL prediction, it is important for both the medical staff as well as the patients. For the medical staff, it not only provides information about the survival of patients, but it also allows them to devise suitable treatments such as immunotherapy for patients. And from the patient's point of view, these TIL quantities provide information to the patients about their cancer immunity and also helps them understand their prognosis as well as understand the particular type of treatments that are provided to them. So TILs have been proven to be important to both the medical staff as well as the patients that are undergoing treatments. However, when we want to calculate the TILs that are present within a tissue section, there are some challenges that are met by the medical staff. The first one is the very large size of these images. So I mentioned that these images are large in size, And because of their very large size, they generally take some effort to analyze and manually assess these images. So I have just added some quantitative values of these very large images. So for example, in the original resolution, this image contains around 1.3, is around 1.3 gigabytes in size. And if we extract a lower level of resolution, which is level 1, it is still contains a high number of, it is still high in size. So because of this large size, generally this requires some manual effort to analyze each of these images separately. The next challenge is there are several rules that have been issued when we want to count the number of lymphocytes or the number of tumor-infiltrating lymphocytes that are present in a given tissue section. And these rules are there are around 7 or 8 rules that we have to follow when we want to count the number of TILs that are present within a tissue section. However, even with the presence of these standard rules, the manual reporting of TIL scores is generally subjected to a degree of ambiguity and inter-observer variability. And the next challenge that we have is because of the combined issue of having very large images, as well as the issue of having a lot of rules to follow when performing this task manually, this task of counting TILs takes roughly about 20 minutes per slide for an expert pathologist to score, which means that assessment of TILs on archival tissues is a prohibitively time-consuming task, even though TILs provide a lot of important insight to both the doctors as well as the patients. Because of all these reasons, there is an interest in converting this scoring into a computational or automatic system. And this is the main motivation of our work as well, where we aim to develop a computational TIL scoring framework. So I'll just give a quick overview of the of few possible approaches that we can take when we solve this kind of question with deep learning models. So I mentioned that the images are very large in size. I'm sure you're familiar with the typical convolutional neural networks or the typical vision transformer networks that have been proposed to process images. If you're familiar with them, you may know that these typical models can generally process images of smaller sizes. For example, images of size 224 pixels by 224 pixels. But as I mentioned, our whole slide images have much more number of pixels than that. So if we want to directly use these existing methods or models that have been proposed in the literature, we will have to downsize these images to a much smaller resolution and then feed them into the model. However, by downsizing these images, we are losing a lot of contextual information that is present in the image. So we are losing all the finer level details of the cell structures or the tissue structures that are present in the image. So downsizing and feeding the image directly to a model does not work in the case of medical images. The next approach that we can take is to split this very large image into smaller patches and then use these small patch level images to feed into a model. As you can see I have just added an example about how much information is stored at a patch level compared to how much information is lost when we simply downsize the image. The issue with extracting these patch level images is that given this very large size of the original image, we will end up with thousands of patches at our hand. And with by having thousands of patches simply extracted from one image means that we again have to have some manual effort to label these thousands of patches that are extracted from one image. So both of these approaches are commonly used in the literature to deal with slide images that are large in size. But given their disadvantages, given the disadvantage of each method, we wanted to avoid both disadvantages and come up with a framework that can handle these very large images and process them without having to have extra manual annotation cost from the medical staff. So with this in mind, we have developed a pipeline which we have named as ANSAC. It stands for Annotation Efficient Attention and Classify Learning Framework. We use the term annotation efficient because we want to highlight that our framework does not require any additional annotation costs from the medical staff. We only require them to provide us the whole slide image together with the slide label, and the rest of the learning is handled by the framework itself. I will now give you a high-level overview of how the framework works. So in this framework, there are two stages. The first stage is the pre-processing stage, and the second one is the model training stage. In the pre-processing stage, what we do is we try to compress the image while preserving the image, the information that is present in the high level, in the gigapixel image. So this compression is done in two manners. In one compression, we simply compress the semantic information that is present in the image. And in the second compression, we try to capture the information of the tissue regions that are present in the image. One thing I should tell you is that when we want to count these lymphocytes, I mentioned that we have several set of rules that we have to follow. So in those rules, there are several steps in which we have to demarcate or identify some tissue regions. For example, the annotator has to first identify the tumor region within the tissue, and then within the tumor region, they have to identify what are the stroma regions within the tumor region. So these are all different types of tissue regions that they have to identify before they count the TILs or the lymphocytes that are present there. So that compression is done in the bottom branch. So after these two compressions are done, we then use the compressed information to learn the class label. So to learn the class label, we use an attention-based network to capture the attention in the image, and then use the attention-weighted compressed image to feed into a classification model, which will provide us the class label. And I have only added the qualitative results just to give you an idea about what our framework is capable of. So here I have added on the left side the manual annotation of an annotator who has annotated the tumor region in yellow color and the stroma region in blue color. And in the top two rows on the right show two methods that we compare against, and the bottom row shows our method. So in addition to providing the class label from the framework, our pipeline also allows them to interpret and visualize what are the regions that are contributing to the class label, and therefore provide a more transparent prediction from the model. So that is a quick summary or overview of our paper. So this paper will be available in bioRxiv towards the end of this year. And this work is done in collaboration with the Peter MacCallum Cancer Centre in Australia. And we invite you all to refer to this paper if you need more details. Thank you. So with that, I come to the end of my talk.
Thank you very much for that informative addressing. Now it's open for the Q&A session. Thank you. Next.
Okay. Can I have one question? Sorry about that.
Yes, sure.
To all the speakers, now you spoke about artificial intelligence. Have you thought about the ethical issues of it?
Yeah, of course, there are ethical issues in the project that I talked about, deepfake detection. But there are still no regulations or laws properly developed with the face of the technological development. But we think those laws should be enforced for people to stop doing that. And about ethical, yeah, there is a very big question there.
Yeah, the UNESCO have actually done a declaration. I'll send it to you as a starting point. So I very much would like to liaise with Professor Saman as well. I know him personally, to see how we can push, because in my opinion, ethics should also be dealt with by the researchers, not people on the other side, because research and ethics are part and parcel, two sides of the same coin. Because you all are the experts in the AI, you all will be in a better position to foresee the ethical issues than somebody looking it from completely outside. So I believe ethics is a critical friend of research. So please try and embed ethical aspects in your research as well. Don't leave it for anybody else to think and do. That's a comment and a question.
That's a very good point, especially in medical research as well. We make sure that all the data sets that we are used under proper ethical guidelines. And we make sure that we don't use any identifiable data in our research. So that is a very valid and important point to raise. So thank you, Professor, for raising that. I think it's important for young researchers as well to keep in mind that whatever research you do, ethics is a very big part of it. So yes, thank you for raising that.
Thank you.
Any other questions or comments?
I hope there is no other questions, so we can continue. Thank you very much for that informative addressing. Next, it's time for the invited speech. So I would like to invite the chairman of NIFS, Professor Atula Sumatipala, to introduce the invited speaker of the day, Professor Eran Edirisinghe.
Thank you. It's a great pleasure to introduce him. Professor Eran Edirisinghe is the Pro Vice Chancellor Research and Innovation at Keele University. He provides strategic leadership to development and management of research and innovation portfolio of Keele University. He joined Keele University in 2021, having previously served at Loughborough University in various academic and leadership roles, including being the head of the Department of Computer Sciences from 2011 to 2014 and Associate Dean for Enterprise School Science from 2015 to 2021. Having received a BSc Engineering Honours degree in Electronic and Telecommunication Engineering from Moratuwa University, Sri Lanka in 1994, Eran received his MSc degree in Digital Communication System and PhD degree in Computer Sciences from Loughborough University in 1996 and 1999, respectively. He joined Loughborough University as a lecturer in Computer Science in 2000. His research expertise is in the area of image processing, image enhancement, video coding, computer vision, pattern recognition, machine learning, and deep neural networks. Professor Edrisinger's research has contributed significantly to the UK industry and economy. He actively contributed to the strengthening of R&I portfolio of Apical Limited, a global award-winning UK-based SME that supplied smart digital camera and display technologies to all top mobile, digital camera and TV brands, which was acquired by ARM UK in 2016 for a record $320 million. His research group partnership with Apical Limited was awarded the prestigious Tappara University Enterprise Award for knowledge transfer in both 2013 and 2014. He has held research grants to a value over 15 million funded by EPSRC. DTI Innovative UK Industry and has collaborated with over 30 industrial partners in delivering high impact research. He has also published over 180 academic papers and 20 confidential industry research reports. A passionate advocate of PhD student supervision and training, he has supervised over 40 PhDs, many of whom hold senior leadership positions in UK and international university and industry. He continues to focus on conducting high-impact applied research in deep neural networks supported imaging applications in digital cameras, drones, automated document analysis system, future smart TV and display system. As you all know, he was at the NIFS a few weeks ago. UK time now is around 5:30. So, they are 5.5 hours behind us. So he woke up at this time, accepting this invitation, and it's ample evidence of his support for NIFS, young scientists, and support to Sri Lanka. I'm really grateful to Professor Edrisinga for accepting our invitation. Thank you. Over to you.
Thank you, Atula. I hope you can hear me.
Yes, we can. Yes.
Yes. Okay. So first of all, thank you very much, Atula, for your introduction, but also thank you very much to the Young Scientists Association for inviting me. It's a great privilege to be talking to you. And when I visited NIFS about a week ago, I was very much impressed by the work the young scientists are doing and the enthusiasm, the hard work, the total dedication of the young scientists just blew me away. And my colleague and myself left NIFS thinking that we should be working closely with NIFS, supporting the young scientists who are there. So this is why when Atula mentioned that it's 4:30 a.m. here, I woke up early in the morning just to be able to talk to you. Perhaps this is not the ideal presentation I would want to do. It's a 15-minute short presentation. So what I was thinking of doing is to take you through a very general presentation and share some of my own thoughts about AI. So to start with, I moved into AI only around 2016 when I realized that the work that I was doing in digital imaging and computer vision really has to be attempted using artificial intelligence rather than the traditional machine learning approaches we were using. I have, during my career, I have always been looking for opportunities where the research funding came through, and mostly looking at new technologies because that is what always kept me driven. So I just decided that I'm going to move into AI, and that's where I started. Once again, I'm a more applied AI scientist, not a very theoretical AI person. So I listened to part of, I couldn't hear, but I saw a part of a presentation from the keynote speaker. Very, very impressive. And this is the type of research we should be doing in AI. But this presentation is quite general. So let me take you through that. Okay, so we all know that AI is kind of, it includes the technologies that let computers mimic the human cognition processes, such as learning and problem solving. So it looks at kind of, it it has the ability to think, and it can gather experience, and it can take input from sensors. This is what the human brain does for learning and problem solving. So AI is trying to get machines to mimic that. And of course, human intelligence is far more powerful. What is happening at the moment is to the attempt is to move artificial intelligence towards human intelligence. There's a list here, which are some properties of artificial intelligence compared against human intelligence. Now, you might think that some of the items, some of the items listed under human intelligence is increasingly becoming available within artificial intelligence, right? So that is what will happen historically. This artificial intelligence, with the advancement of technology, with the advancement of the humans attempting to improve it, it's going to be moved towards human intelligence. Of course, I'm not going to answer the question whether artificial intelligence will one day replace human intelligence. I feel we might be 10, 20 years away, but it might even not happen. It depends on the technology. At the moment, currently, there's a massive bottleneck. The bottleneck is mostly coming from the hardware, especially when hardware is constrained. Look, if you think about the technological advancement in mobile devices, right? You might have seen that in the last 2 years or so, there aren't that many new applications that are groundbreaking that are coming through mobile devices, right? It's because the mobile devices and the hardware within the mobile devices are at the moment unable to run, for example, large language models. You know, ChatGPT, right? And ChatGPT is a large language model. It has a remarkable ability to do so many things. But unfortunately, at the moment, full versions of ChatGPT cannot be run on mobile devices. And we just recently submitted a research grant application trying to solve that problem with a group of industry partners. But I'm just trying to show you what is happening at the moment. Can we move to the next slide? Thank you. So in order to get the best out of artificial intelligence, we need to try our best to move it towards human intelligence, right? Now, the technology will develop over the years, and this will happen slowly. But as researchers working in multidisciplinary areas, we can actually make this happen faster. So what I believe that can happen very strongly is that humans could support the current AI technology to work in a much better way if they work as multidisciplinary teams. Okay, so AI is a multidisciplinary field. It draws on a range of technical and non-technical fields, including, so I have listed few here. I've thought about a number. Of course, I'm sure there might be some of you listening, or you excluded another area. I agree, this is not a full list, but just an attempt for me to list them. So of course, definitely computer science, where we talk about neural networks, and computers themselves, the computer hardware, the engineering side of computer hardware, it contributes to artificial intelligence. Natural sciences, physics, chemical sciences, materials used in the hardware designs are important as well, because that is what drives the technology. That is what makes the computers faster. Mathematics, definitely. Most of the feature extractors, the classifiers and everything is heavily mathematically driven. And therefore, mathematics forms the basis of AI. Psychology, philosophy, because it's a thinking process, right? AI attempts and has successfully implement some of the philosophical thought processes in the designs of the neural network architectures. Social sciences play a key role. We are working with humans. AI is working with humans. Therefore, anything to do with social sciences will impact AI, and AI will impact social sciences as well. Legal and ethical issues, a major problem right now. If there's any resistance to artificial intelligence, we all know, I think the previous individuals who are raising questions raise this. It's very critical, and within the UK, AI has been, suddenly pulled down with a string and attempting to bring in legislation to control the use of AI and make sure that we use AI in a very we consider ethics, and we consider legal aspects as well. So if we work as a team, it can work very well. So collaboration across this discipline is necessary to develop AI systems that are effective, efficient, and responsible. Okay, I have one slide, which can we move to the next slide, please? Okay, so I'm going to take you through a few examples of some of my research that where I could explain how we work as multidisciplinary teams, and how it is important to attempt to use the multidisciplinary approach to get the best out of AI. Now, I don't have slide pictures for some of these items, and this is not an exclusive list as well. I just picked up a few of the examples. So think about image enhancement. So the image enhancement, I don't have a representative picture here. So the work that I have been doing mostly during my career is around image enhancement. So that is to try and remove noise, remove various aspects that makes images not look real. So make images look more realistic. Previously, I was using machine learning mostly for example, very simple things, noise removal, right? Very simple way of removing noise. We've done that work, but we specifically made use of the sensitivity of the human visual system, right, in order to develop our algorithm. So they were very specific, because we looked at how the human brain looks at human eyes looks at images, and how the brain processes them. So we came up with some very unique image enhancement techniques using machine learning. More recently, we have replaced all of these machine learning based approaches with AI approaches, right? Because AI can do remarkable things. Okay, so one of the very recent projects that we completed is to remove noise, but remove about 10 different types of noise using one neural network, right? Previously, what had to happen within cameras is to have, let's say, 10 different noise removal techniques all connected together, but we were able to do all of those 10 different noise types removals with one network. And this is the power of neural networks. And the quality is much better as well. So all the work that I do, I make sure that they end up in an application, in a device. So I always work with companies who need the technology. Another project that quite a significant project I have been working is with Emirates airline-owned Dubai Desert Reserve Desert Conservation Reserve, which is a research facility based in Dubai, and we looked at multiple projects. So they have wild animals, and we've been detecting them. We've been detecting trees and various types of trees. Now, why I mention listed all of these projects is that we as computer scientists, if we attempted to do any of these projects, we would have never got anywhere. First of all, we know how the neural networks work, but if we don't know what in practice how humans would try to detect these objects, right, you can't get the best out of AI algorithms. So it's always important to try and work with those people who might be manually trying to identify these objects, and try to ask them various questions. Okay, how do you identify a particular tree? How do you identify a particular animal? Because that gives us the ability to fine tune some of the deep neural networks, and that stops us having to use massive amounts of data. Okay, so we have got two or three different issues here. Neural networks, right? Especially if you are using very deep neural networks, they are computationally very complex, right? The question I'm asking is, do you actually have to use very deep neural networks? Can you use shallower networks, right? Because if you use very deep neural networks, yes, you can be accurate, but you need a lot of data to train. Why don't we try to attempt to use human knowledge to try and do parts of that pre-processing before we feed the data in? Because that allows us to use shallower networks. That therefore allows us to run these networks on devices which are computationally constrained, like mobile phones. Okay, so that's fundamentally one big question to be answered. And the next thing is that sometimes people use deep neural networks as black boxes. Okay, and this is when non-computer scientists would try to attempt to use deep neural networks, or just any neural network, in solving a problem. As a computer scientist, one should be able to actually go deeper into the architecture of the deep neural networks to simplify it, and to ensure that by simplification that we can train these neural networks more accurately with less data. So one of the biggest issues that I see in people attempting to use deep neural networks is where they use it as a black box. It does not work, right? So it is very important that computer scientists are involved. It is also important that people who knows the subject, for let's say medical imaging, medics needs to be involved, right? But is that all? What about ethics? What about the legal aspects? What about data protection? So people from multiple disciplines needs to be involved in working together to attempt to answer these questions. I've done some of the projects, remarkable projects, is that where we were trying to detect some animals who were only visible in the night, right? But we had only few images of them because they are rare animals. We managed to train deep neural networks in a way that even the rarest animals can be detected with the same accuracy. There's a challenge around training neural networks, and when the data within classes are unbalanced, not balanced. And there are some remarkable ways to try and overcome them. I wouldn't be able to go into details here, but that's one of the things. I have recently worked on using ChatGPT and try to get ChatGPT to get implemented on mobile devices. This is a hardware problem. So I had to work with hardware engineers because they know what exactly needs to happen. And that project is sponsored by Samsung, and Apple has also indicated some interest. So lots of work, but multiple disciplines needs to be working together. And also text detection recovery. Text detection using AI is not a big issue, but one of the interesting projects I have recently done is to try and recover so if you take a picture of a word that has already been written, can you track the path of the letters? Can you track the pen path? Because if you can track the pen path, there are things that you can do which cannot be done if you just consider a text piece of text as an image. So that was for a Japanese company called Wacom, who has got tablets and electronic pens, digital pens. So I just gave a very brief summary of various ways of working as multidisciplinary teams. AI, of course, we all agree, AI can be applied in almost any area. I could find a solution using AI for many problems, from finance to human sciences as well. And so it's remarkable. But what is important is that each person having different expertise in different areas needs to work as a team. If that happens, you can get the best out of AI. So I will stop there with that message. So do not attempt AI as expert of your own area. Work with teams, understand the people, work with the people who understand the problem. Try to talk to them as to how they will manually or as a human try to solve the problem. Then try to bring in your own expertise to AI, right? I'm not saying you are a computer scientist, but you could be a human scientist who might be interested in certain aspects of AI and how AI impacts on humans. That's important as well. Okay, so I'll stop there, and I'm happy to take any short questions. Thank you.
Please proceed with your questions if there's any.
Okay.
In the absence of any questions, Iran, can I ask you to reiterate what is happening with ethics front in AI in UK?
Yeah. So lots of things are happening in the ethics front in the UK. First of all, there's a group of government. There's a government initiative to get together many people from different subject disciplines to work on an ethics framework, and there is already a government ethics framework, but due to the speed at which AI is developing, due to the speed at which AI ethics-related issues are being raised from many sectors, this has to be a dynamic group that keeps changing the kind of ethics guidelines. Universities were actually got a shock of around AI, mostly with the ChatGPT becoming more popular and students using them for assessment. So the universities are at the moment following the government guidelines, right? Assessments have been changed. The way that assessments are being done is being changed to try and respond to that challenge. But at the same time, it's very clear the benefits of AI should not be undermined, right? Always there's a challenge. So the ethics frameworks are being tightened. Legislations are coming in. Specifically, of course we have a very strict GDPR compliance approach that we all follow, especially within medicine and health sciences, or where in subject areas where human data is being used. But it's a significant attempt everywhere. But it's always very dynamic, Atula.
Yeah. Thank you so much. I just want to add
Thank
to
you.
that. Day before yesterday, the funding bodies, the UK has said you can use AI to facilitate grant applications, but you can't use it for grant review. So it's another development as well. So it's interesting, and I wanted to highlight because the young scientists need to think about ethics as well. Even in fundamental studies, I think you can think about ethical aspects when it comes to development. So I just wanted to highlight that. Thank you very much, Iran, for your
Thank you, Atula. Thank you for to the Young Scientists Association for having me, and I will be very happy to work closely with you as a mentor if you need my help. So thank you very much. I will leave the meeting now, if that is okay.
Thank you very much for that informative addressing, sir. Next, I would like to invite the conference editor-in-chief, Professor Nasrin Madikar, to address the gathering.
Very good morning to everyone. Thank you very much for the master of the ceremony. Honorable Chairman, Honorable Director of NIFS, distinguished scientists, and ladies and gentlemen. I am very much feel honored to have been appointed as the chief editor for the Young Scientists Conference on Multidisciplinary Research, which is organized 5th time this year. So thank you so much for the Research Council to consider my name to lead this program. So I have been asked by the co-chairs to give a few words. So first of all, a warm welcome to all delegates to the conference, IBO1. So actually the purpose of this conference for the young scientists multiple. So the first of all, it will be a platform for young scientists and early career scientists to disseminate their research findings in a public forum like this. And it also serves as a meeting point to discuss, collaborate, and network with fellow colleagues in Sri Lanka and abroad. And also, it provides an opportunity to groom the young scientists to take the leadership in the future. So as an editor, I have played a role as shown in this picture. Actually, I am a mentor for the young scientists. Okay, so actually I am trying to facilitate the, among the young scientists, the cognitive level 5 development in them. So according to the Bloom's learning taxonomy, cognitive level 5 stands for research, innovation, creativity, and patenting, that kind of thing. So by engaging this kind of a conference, they can develop their organization skills and the way of preparing presentations, way of preparing abstracts, and submission and getting feedback from reviewers and responding to the feedback. All these are coming under cognitive level 5. So this conference provides an opportunity for them to fulfill the requirement of cognitive level 5. So as a part of the conference, we came to a decision that we should conduct a pre-conference webinars The first of the free conference webinar held in October 3rd. So the topic is how to write a good abstract and create an effective presentation. Second of the pre-conference webinar is patenting your research. Third one is effective ways of stress management among the postgraduate students. So all these three has immensely benefited for the young scientists of this conference. So in this year, we have divided the conference tracks into 5 different categories. First one is biological sciences. Second category is chemical sciences. Third category is physical sciences. Fourth category is social sciences. And fifth category is mathematical sciences. So as a good news for the delegates of this conference, so the conference popularity is growing year by year. This year we have received a total of 159 submissions, and each and every submission was evaluated by at least 2 reviewers. And in this year, we have paid close attention to the following 3 criteria. The first one is novelty or originality of the research. And second aspect, we have paid attention to the accurate structure of the abstract. And third thing, we paid attention to the word count, appropriate use of keywords. And based on these things, we have done the evaluation of the submissions. So the review outcome under different categories are shown below here. Under biological sciences track, we received a 62 submission and only 50 were accepted. Under chemical sciences category or track, we received 51 submission, only 45 submissions were accepted. Under physical sciences track, we received altogether 17 submissions and only 15 were accepted. Under social sciences, we received 20 submissions and only 15 were accepted. Under mathematical sciences, we received a total of 9 submissions, only 5 were accepted. This is the review outcome. And we have done the process of a review process in a timely manner, and punctuality was maintained. And we have, at the beginning itself, we have appointed the handling editors, and also we have selected a list of reviewers for reviewing abstracts submitted under different tracks. And whenever there's a delay, we have sent reminders for the reviewers to send their feedback as soon as possible. And as soon as possible, we receive the feedback from the reviewers. We have sent the notification whether it is accepted or rejected. And also on the timely manner, we received camera-ready submission to speed up our process. So in this, it is a very formidable task. A huge amount of work is involved. So there are so many hands gone into this one. They collaborated and worked together. First of all, I would like to thank the Honorable Director for giving unwavering support for this conference. And also, I would like to thank the handling editors and reviewers for their time and effort, and also the co-chairs, the entire membership of the Young Scientists Association. They have worked together. And also finally, I would like to thank all the non-research divisions who gave support to conduct this conference successfully. So lastly, I would like to wish all our delegates a very pleasant stay and fruitful discussion during the conference. With that, I would like to wind up my talk. Thank you very much for your listening.
Thank you very much, sir. Now it is the time to launch the conference proceedings. For this, I would like to invite Advisor to the Young Scientist Association NIFS, Dr. Lakmal Jayaratne upon the stage. Thank you very much, sir. Next, I would like to call upon stage the co-chair of YSCMR 2023, Mr. Supun Nayanajit, to deliver the vote of thanks.
Thank you, Kumudu. A very good morning to you all, the chairman of NIFS, the director of NIFS, distinguished guests, and all of you who are joined online and those who are within the institute. It is a great honor to propose the vote of thanks on behalf of the organizing committee of YSCMR 2023. First and foremost, I would like to express my gratitude to the keynote speaker, Professor Saman Halgamage, Ms. Rosindri Pereira, Ms. Deshani Poddenige from University of Melbourne, and the invited speaker, Professor Eran Edrisinghe from University of Kales, for accepting our invitation amidst your busy schedule. Organizing an event of this scale would not be possible without funding. So, I would like to thank our exclusive sponsor, Bank of Ceylon, Sri Lanka Microbial Biotechnology Program of NIFS, IRD, RR Constructions, Gamini Transport Services, and St. Anthony's. Further, I would like to extend my sincere gratitude to the chairman of NIFS, Professor Atula Sumutipala, the director of the NIFS, Professor Saluka Kodituaku, and all the NIFS scientists for guiding us throughout the organizing process. And also, I would like to thank the secretary and accountant of NIFS for providing us with the necessary facilities. Moreover, as the co-chair of YSCMR 2023, I would like to thank our editor-in-chief, Professor Nasrim Marika, for his guidance throughout the organizing process and to the editorial board. I would like to take this opportunity to express my sincere gratitude to all the reviewers for their immense support throughout the reviewing process. This event would not be a success without their encouraging advice and guidance. Further, I would like to extend my heartfelt gratitude to Dr. Lakmal Jaisinghe, the advisor to the YSA. My thanks go to the session chairs and the judges of all the technical sessions. An event like this cannot happen overnight. We have been fortunate enough to be backed by a highly dedicated organizing committee. I am very proud to share that we have a very enthusiastic and committed group of research assistants and volunteer researchers at NIFS who deserve a big thank you. I would also like to thank the staff of NIFS for their support in numerous ways, especially Science Education and Dissemination Unit, Computer Division, and those who have gone unmentioned. Further, I extend my sincere thanks to all the authors, co-authors, and their supervisors for their contribution by submitting abstract to make this conference a success. Finally, on behalf of the organizing committee, I would like to thank and congratulate all the presenters for presenting your research finding at YSCMR 2023. We thank you all for being with us today. Have a productive and enjoyable day.